Start stream. Oh, you're good.
Hi everyone.
See if anybody starts typing.
See if anybody says anything. If you can hear me, say hi in the chat.
Let me know if you can.
Okay, thanks. Hi. We'll get started in just a minute. I'm going to wait for people to sign on. Hi, Jonas. Okay, so hello everyone and welcome to the Twitch review. I am going to wait just maybe like 2 more minutes to start, but for those of you who are here, I'm going to go over this spring 2020 practice exam. It is in your notebooks and it's also posted on our course website. So if you go to our Stat 100 website and then go to practice exams, you'll be able to see a blank copy of this exam, but this practice exam, and then the answer key is also there. But I guess if you're watching this, you'll see me fill in all the answers, so hopefully you won't need that. But if you want to check yourself for any of the practice exams, they are on the website. Oh, someone said happy late birthday. Thank you. It was my birthday on Saturday. So that was exciting. One other thing I wanted to let you guys know is that I have been sending emails about exam too, and some people are telling me that one of them, like the very most important one that I sent, went to their spam folders. So if you have any questions about the test, exam 2, double check that you got my email. Look in your spam folder. I also post all of the emails that I send on Compass, so you can always double check there. But hopefully I fixed that situation because it looks like the one about the Twitch review went through, so that's good. Oh, thanks, guys. Oh, it went to their spam folder. Yeah, I don't know why it did that. I'm trying to figure it out, but it seems to be fixed. So sorry about that. But basically, exam 2 is going to be very, very similar to exam 1. It's going to be on Compass. It's going to be the same length. You're going to have 90 minutes again. It's basically the same thing. Okay, so let's see, what time is it? 7:03. I think we're going to go ahead and get started. So this shouldn't be as crazy as the last Twitch review because I figured out how to not make it public. The last one, there were like all these random people here, and that should not be the case this time. But like I said, I'm going to go over this spring 2020 practice exam. I will give you guys some tips for what I would think about if I was taking this exam. And then at the end, we'll see if there's any questions. If you guys have questions, you can always comment in the chat. All of the TAs, my TAs are here, a couple of them, and they are going to be monitoring the chat, but I'll try and glance over. I have like 2 screens, so if I look over here, I'm looking at the chat. And I'll try and answer any questions that seem like I should answer them right away. So here goes nothing. we're going to go through this whole thing. So you guys will notice there's all these directions about in-person exams, which you don't really have to worry about. You will get a normal table again on exam 2, and you can just click on, there's a link in Compass that says you can get a PDF of the normal table from me, or the exam is open notes, so you can look at one in your notebook if that works better. But exam 2 covers chapter 6 part 2 all the way to chapter 12. So in other words, it covers box plots, correlation, regression, and probability. So those are the topics, and I am going to start with I think the correlation questions are first. So let's go ahead and get started. Yes, I just saw someone ask, are you posting this later? Yes, of course. I will post it hopefully tonight, but if not, it'll be up by tomorrow. Okay, so questions 1 through 6, it says we're looking at scatter plots, and we want to determine whether the correlation coefficient is appropriate for analyzing the plots, and then if so, you want to pick the R value that represents each plot. So plot A, let's see, is this gonna, okay, there we go. Plot A, the first one, actually if I look at that, remember the correlation coefficient tells us the strength of the linear relationship between our X and Y variable. And plot A, it looks like there's actually no relationship really. Like if I tried to draw a line of best fit through those points, I wouldn't know if it should have a positive slope or a negative slope, or really what is going on there. It kind of just looks like a big blob of points. So here I would actually say that this is a good example of no correlation, no linear relationship. For not appropriate to use R, that would be if there was a relationship, but it's just not linear. So here, R, the correlation, would correctly tell us there's no pattern in plot A. There's no relationship between X and Y. Let's see, plot B looks like, okay, if I tried to draw a regression line through all these points, it looks like it would have a positive slope. So plot B is definitely going to have a positive correlation. The question is it 0.8 or 0.3? So we know it's not 0. It's not going to be negative. And here, this actually looks like a pretty strong correlation. I would guess right away that it's going to be 0.8, but if you were unsure, you could always look at the other positive correlation and then make a comparison. But let's keep going. So plot C is definitely a negative correlation because my line of best fit would slope down. And then just looking right at plot D, this is also another negative correlation. So plots C and D are both negative, and it looks like D is stronger than C. D would be closer to -1. So out of -0.8 and +0.8, I would say that plot D is -0.8, oops, sorry, and -0.3. That's what I meant. The two negatives, and then plot C would be -0.3. And then plot E and plot F. Plot E is kind of, we've got something weird going on here. It's like kind of two separate plots combined into one, and it looks like both of those separately would have a negative correlation, but if you combine them, we'd probably have to draw our line of best fit something like this. So R, there is a relationship here, but I don't know if R would correctly capture that. So plot E would be the example where it's not appropriate to use R just because there's not a linear relationship, or I guess there's two linear relationships. And then plot F is definitely a positive correlation because the points slope up and to the right. And if I look at plot F, the positive correlation, and then plot B, plot F isn't as strong. So plot F would be 0.3. So this first question is kind of just looking at the scatter plots and trying to figure out what the correlation coefficient is for each of them. And each one of them, it doesn't say this here, does it? No, it doesn't say each one would be used once, but I have a similar question to this on the exam, and each will be used once. So I'll tell you that if that's the case. But if there are any questions on that, let me know. It looks like not yet. So we'll go ahead and go on to the next one. So these questions, I've actually gotten a lot of questions about this particular question at office hours. So it says, we are looking at the following situation. For each of the following pairs of variables, check the box that describes the correlation coefficient R and will be used exactly. So we're going to go ahead and I'm going to give you guys a rundown of how to do these problems. Oh, hi. Someone said, sorry they're late. It's okay. Today is a Monday. It is a crazy day, and I feel like I've been late to everything I've done today. So don't worry about it. All right. So if I was going to do this, I would ask myself 3 questions about each of the sets of variables. So the first question, let me see if I can write this down here. The first question we want to ask is there a relationship? And if the answer is no, then R is probably 0. R is probably 0 if there's no relationship. If the answer is yes, then you have to decide, is it positive or negative? So is it positive or negative? So that's question number 2. And then lastly, you want to ask yourself, is it perfect? So if you answer all these questions slowly, you'll definitely get the right answer for these. I think the problem is a lot of people just try and think of it right away without asking the question. So if you're struggling with these, definitely ask yourself the question. So number 7 says amount of exercise and percent body fat. So is there a relationship between these two things? Yeah, right? Most people, if they're exercising, they probably want less body fat. So there's definitely a relationship. All right. Next, is it positive or negative? So I know basically for number 7, I know the answer is probably not about 0. Is it positive or negative? So if there's a positive relationship or a positive correlation, as one of the variables goes up, the other one goes up as well. If there's a negative relationship or negative correlation, as one of the variables goes up, the other one goes down. So let's figure out if it's positive or negative. This one is amount of exercise and percent body fat. So the more you exercise, you should have less body fat, right? Because exercising burns fat. So this should be a negative correlation because more you exercise, less your percent body fat. So it's definitely going to be negative. And then the question is it between 0 and -1? Is it a general negative correlation, or is it exactly -1? So the last question is it a perfect correlation? So with the last question, you can always ask yourself, you can give one of your variables a number and say, knowing that, do I know exactly what the other one is? So if I tell you guys I exercise, I don't know how much I exercise, 3 times a week, could you say exactly what my percent body fat is? No, right? Maybe you could guess, but we can't say exactly. Knowing X doesn't tell us exactly what Y is. So this is an example of just a general negative correlation. It says check the box, so I'll give a little check. So this is a negative correlation, but it's not perfect. Okay. Let's go to the next one. Same kind of thing. Ice cream sales and temperature. So is there a relationship? Yeah, this is a pretty classic example for correlation and statistics. I feel like people always use this to show that correlation does not imply causation. So there's definitely a relationship. As the ice cream sales go up in general, so does the temperature. So this is a positive correlation because as one goes up, the other goes up as well. And then if I tell you it's 80 degrees, do you know exactly how many ice cream sales you'll have in a place? No, right? You could kind of guess, but you don't know exactly. So this is just a general positive correlation. All right, so far so good. Weight in pounds and weight in kilograms. Definitely a relationship because they're the same variable. So as one goes up, as your weight in pounds goes up, your weight in kilograms goes up too. So this is a positive correlation for sure. And Is it perfect if I tell you my weight in pounds? Can you give me my weight in kilograms? Yes, right? You can just do a calculation to figure that out. So anytime you have two variables just with different units, that's, I think, all the time is going to be a perfect correlation because you can easily convert from one from the other. So this is a positive correlation because as weight goes up, regardless of what units it's in, it's going to go up. And it is perfect. So that's exactly 1. Exactly positive 1. Okay. Number of siblings you have in GPA. Is there a relationship between those? Is my first question. How many siblings you have in your GPA? Hopefully not. We could actually look at this data. I think I've asked you guys both of these questions. There's no relationship. So that's an example where the correlation would be about 0. And then I guess if I was reading directions here, I know the last one has to be exactly -1 because it says every column will be used exactly once. But we can explore that as well. It says 2 variables that add up to 1,000. So there's definitely a relationship here because they always add to 1,000. The question is, as one of them goes up, what happens to the other one? So if you don't know right away, you can always test this out. Like I can test out, I always like to test out 1, 2, and 3. Like, let's see. If x and y, if x is 1, 2, and 3, what happens to y? Does it go up or down? So 2 variables that add up to 1,000, that just means x plus y, if I want to call my variables x and y, equal 1,000. So if x is 1, y has to be 999, right? If x is 2, y has to be 998. If x is 3, y has to be 997. So I can see just from this table, just from testing it out really quick, that as x gets bigger, y is getting smaller. So I know it's a negative correlation, and I know it's perfect because any value of x, if I told you x was 500, you know exactly what y has to be based on that information that they have to add to 1,000. So with these, I can't stress it enough to make sure to take your time. People just look at it and be like, oh, I think it's this. But again, if you slow down and ask yourself those questions, you're bound to get the right answer. All right. Before we move on, I'll see if anyone has any questions. Let's see. Somebody said, will you give us the conversion on the test? I'm guessing that's for the weight in pounds and weight in kilograms. If you need it, yes, but you're not going to need it. I'll just tell you guys now, you're not going to need that for exam 2. So, yeah. General question. It was hard for me to do the work needed and also answer the questions. I would agree with Jonas, one of the TAs. He said to have scratch paper. I always tell students with the test, if you're having trouble with timing, the best way to fix that is to do more practice exams. The more practice exams you do, the more familiar you'll be with the questions, and then the quicker you can do them. So I would recommend for all of you guys for studying, before Wednesday, do one of the practice exams as a real exam. So basically sit down for 90 minutes and go through it with your notes. And then at the end, when you're completely done, grade yourself. And that will give you a pretty accurate representation of what your grade will be. A lot of people peek at their notes when they're taking the practice exams. And there is a lot of research that shows that taking an exam in an exam-like condition is best for studying. But yeah, having scratch paper, really, I think being familiar with the material and the types of questions that we ask is the best way to prepare for that. Okay, somebody said, since it's open notes, can we have the formulas written down on scratch paper, right? Yep, it is fair game, which this is good for you guys. Usually they have to memorize all this stuff, but honestly, now I'm questioning. I'm like, maybe I shouldn't make them, because students are doing totally fine. Let's see, what else? Are you going to give us the information about a deck of cards, or do we need to memorize it? I'll give you the information about the deck of cards, but again, since it's open notes, you can just have, if you want a deck of cards with you, or if you want to look at like a picture of them, that's totally fine. Okay, somebody else asked. Some of the homework on Long Cap is still a fill-in-the-blank table. Is there going to be tables with multiple choice options for the blanks? Yes, there will be. I think there's a couple questions that have a table. It'll say like blank 1, and then you'll have to fill that in. The exam is going to be multiple choice and fill in the blank. Are the previous exams historically similar to the current years? Yes. The practice exams are, I mean, they're not exactly the same, but they're pretty similar. There's only, I guess, so many ways that we can ask these questions. So they're the best way to study for sure. Cool. All right, let's move on to the next part. So it says parts A, B, and C pertain to this situation. Compute the correlation coefficient. All right, so we have these summary statistics, and this is, okay, so this is kind of an example of how it will be on your guys' test, where, see how like question 12, question 13, and 14, you have to fill those in, but then I guess honestly, in order to do this question, you have to fill in the whole table. So let's see. Let's do your number 12. So in order to find the correlation coefficient is the average of the products. So we can find all of the products of the z-scores and add them together and divide by, let's see, how many are there? 1, 2, 3, 4, 5. So I'm just going to go ahead and find all the z-scores for x first. So remember, the z-score formula from exam 1 is still and always will be value minus average divided by SD. So let's see, for number 12, I can say that my z-score is equal to 1 minus the average for x is 4. And the SD is 2. So it looks like it is negative 1.5, which is a, oops, no. Oh no, I lied. It is B, right? Negative 1.5. And then, yeah, the rest of them, we can just kind of go down and do the same thing. So for this one, for 3, for the x, I can do 3 minus the average is 4, divided by 2. This should be negative 0.5. 0 is given to us for the next x, z-score for x. And then, let's see, the next one, 5 is my value. 4 is the average. 2 is still the SD, so this should be positive 0.5. And then the last one is positive 1.5. And the total should always be 0 for the z-scores for both of these, actually, because the z-scores are basically deviations in the numerator and then divided by SD. That looks good. Z-scores for y, I can do the same thing. This y value is 2. Let's see, does y have different statistics? Yeah, the average is 3 and the SD is 2. It's negative 1 over 2, negative 0.5. And then I'm just going to assume that you guys can do the rest of these. This should be negative 1.5. Let's see, this one should be 0.5. And then this one should be 1.5. Okay, and then the very last column is for us to find the products of the z-scores, because we want to make sure x and y are paired with each other for correlation, right? Because those make up a point. So the products are that just means to multiply the two z-scores. So for the first one, it would be negative 1.5 times negative 0.5. So 2 negatives gives me a positive. This should be 0.75. Same with this one, this should be 0.75. 0 times 0.5 should be 0. This one should be 0, and this one should be 2.25. And then if I add all these up, I end up getting 3.75. So we're almost there. We did part A. Part B, what is the correlation coefficient? Remember, the correlation coefficient is the average of the products. So I would just take all of them, add them together, and I end up getting 3.75 and then divided by 5 since there's 5 points. And that gives me 0.75. So my correlation is positive. It is 0.75. That looks good. And then part C, the very last part, it says the x and y refer to the original x and y given in part A. What happens to the correlation R if we do all of these things? Remember, if we do the same thing to every number, either every x or every y, then the only time R changes is if we multiply or divide by a negative. So the first one says if we add 5 to each y value, here R is just going to stay the same. We're literally, if you think about the scatter plot, we're like shifting it over to the right. Oops, sorry, y value. We're switching it, shifting it up, not over to the right. If we had 5 to each x value, that would happen. Multiply each x value by 2. Again, R is going to stay the same. We're just multiplying all the x's by the same number. If we divide each x by -4, then R is going to switch signs. So R would go from 0.75 to -0.75. And then if we switch all the x and y values, we're doing the same thing to all the values. So R is going to stay the same. You can think of that like the correlation between height and weight is the same as the correlation between weight and height. Okay, so I think that's it for the correlation question. So let's go ahead and we're going to move on to box plots. So it says we're looking at the following set of numbers, and we're going to need to answer all of the questions about statistics for the box plots, and then the last question we want to pick which one looks like the box plot. So it says the median for this set of numbers is what? So the median, remember, is also known as Q2, second quartile, and the median is the middle number when we line up the numbers in order smallest to biggest. So here, let's go ahead and see, are these in order? Yeah, it looks like they're in order from smallest to biggest. So the middle number is here, right? Yep, there's 4 on each side. And so there's not one middle number, instead there's 2 middle numbers, so the median is just going to be the average of 3 and 6. So 3 plus 6 is 9, divided by 2 is 4.5. And then let's see, the first quartile is the 25th percentile. So what we can do is look at all the numbers to the left of the median and pick the middle number. So in this case, there's also not a middle number, so the median, or the Q1, the 25th percentile would be in between 1 and 3, so that would be 2. Kind of similar for the third quartile, the 75th percentile, we can take all the numbers to the right of the median and pick the middle number. So middle would be between 6.5 and 7.5, so that would be 7. And then the IQR is another measure of spread. It's the third quartile minus the first quartile, or in other words, it's the middle 50% of the data. So on the box plot, it's the box. So in this case, we would have 7 minus 2, which is 5. Okay, let's see. I'll give you guys just a minute to see if there's any questions so far. All right. So are there any outliers? Remember, outliers are just data points that lie outside most of the other data points. We can actually calculate these mathematically using these rules. So I'll start with the low outliers. So low outliers are any numbers less than Q1 minus 1.5 times the IQR. So I'm going to figure out what that is and then look at my list of numbers, my original list, which was up here, these, and I'm going to see if there's any numbers lower than whatever this ends up being. So Q1 was 2 minus 1.5 times 5. And that gives me negative 5.5. And if I look at my list, there's no numbers less than negative 5.5. So I'm going to go ahead and say that there are, it just says, are there any outliers? Well, there's no low outliers, but we have to check for high outliers. So I'm kind of running out of room here. Let's see. High outliers, very similar, are numbers that are greater than Q3 plus 1.5 times the IQR. So Q3 was 7 plus 1.5 times 5. And this gives me 14.5. So again, I'm going to double check my list. Is there any number greater than 14.5? It looks like there's one. 15. 15 is greater than 14.5. So there is one high outlier. So I can even say there are no low outliers, and then there is one high outlier. So my answer would just be yes, a high outlier. Looking at the chat, it says, is Q2 also the median? Yes, Q2 is the 50th percentile, aka the median. When do we not include the middle number when looking at the first quartile? So basically, anytime you're doing these calculations, don't include the median when you're calculating Q1 and Q3, even if the median is a number on the list, just to be consistent. Where do we get 1.5? So 1.5 is actually just it's just part of the formula. Someone said that, but it is these formulas are very common for determining if a data point is an outlier. Do you always use 1.5? Yes, unless, I guess, outside of this class, I guess if someone told you specifically not to and they were a trustworthy source, then maybe not. But for this class, yes, and that's the most common thing. Cool. So now, which of the following looks like an appropriate box? Oops, wow, this should say box plot, model, box plot, not model, for this set of numbers. Okay, so we need to find one that has no low outliers and one high outlier. So it's not A. A has no outliers. Remember, the outliers are plotted as little dots. So B has a high outlier. B looks good. Maybe. We're going to investigate it a little more. C has a high outlier and a low outlier. So it's not C. It's not D. D has no outliers. And then E has one high outlier too. So the question is it B or E? Well, remember on the box plot, this line right here is Q1, this is Q2, and this is Q3. So if we look, Q1 is, it looks like about halfway between 0 and 5. 2, it looks like it'd be about 2, right? And then the median is 4.5, and then Q3 is about 7. This B looks good. If I look over here at E, it looks like E, so E looks fine, except the lowest number, it looks like, is at about 0. And on our list, the lowest number is -3. So this plot B is actually better, if I had to pick. What if there is an odd number of numbers? Which quartile would you include the middle number? If there's an odd number of numbers, just don't include the median. So basically, if you have something like, let's see, if you have 1, 2, 3, 4, and 5, 3 would be the median, and then Q1 would be 1.5, and Q3 would be 4.5. So to be consistent, just don't ever include the median when you're calculating Q1 and Q3, regardless of if there is an odd number or an even number of data points. Okay, cool. So definitely know how to calculate the statistics for a box plot. Obviously, I can't have you guys draw a box plot on Compass, but know what they look like, and you should be good for the box plot questions. Next set of questions, it says pertain to the following scenario. Is this in the very first survey of the year, we asked the students, how old is your mother and how old is your father? So here are the summary statistics, and let's go ahead and answer questions about this plot. Okay, so it says the SD line and the regression line are shown. Which one's which? So remember, the SD line is the steeper one. So that's going to be line A. A is the steeper one. The regression line is the flatter one. What is the correlation closest to? Here, if I look at this nice scatter plot that they gave me, it's definitely a positive correlation, right? I'm gonna get rid of these. It's not negative. The points are sloping up and to the right. And I would say if I was just glancing at this is a very strong correlation. Like the regression line and the SD are very, very close together. An easier way to do this is to kind of, you can always think, okay, the SD line, we know, assumes that R equals 1. So what the SD line is if there was a perfect correlation, that's the line that all the points would be on. And then we know our correlation is positive, so it has to be between 0 and 1. If R was 0, so here's the point of averages right in the middle. If R was 0, our regression line would be totally flat. And so then we can see, okay, if our regression line was closer to 0, like say we had something like this, then maybe we'd know, okay, it's about 0.2. If it was like halfway between the R equals 1 and R equals 0, it would be closer to 0.5. But we can see that our regression line is very, very close to the SD line. So this one is going to be 0.8. And on the Compass exam, I'll make it, because obviously you guys can't draw on the Compass exam, so it'll be very clear when we ask for the correlation coefficient. Let's see, what is the average mother's age? Okay, well, I said here's the point of averages. The point of averages is always where the two lines meet. And it looks like, I don't know, about 50. 50 is probably the closest one for mother's age, right? If I just go here and then go down. Yeah, right about 50. What is the average father's age? It looks like, honestly, about 50 too. They're both about 50. Okay, last question. It says, what is the point circled? We think the point circled in the scatter plot is an outlier. What does removing this outlier do to the correlation coefficient? So here's the circled point down here, and it's kind of far away. It's actually dragging my correlation coefficient to be down. What the heck? Why is this doing that? So if we got rid of it, it'd be easier to draw a line through all the points. So I would say removing this outlier actually raises or increases the correlation coefficient. Is this exam 30 minutes shorter than the last one? Definitely not. It's still 90 minutes. All right, 32 says points above the regression line have positive prediction errors, right? If you're above the regression line, that means that you are higher than what we predict. The average of the prediction errors is always 0. Definitely know this. Always 0 because the positives and negatives cancel out. And then I guess this is actually the last one for this question. What must be true if you lie on the SD line? So I guess there's a couple things that must be true if you're on the SD line. One is that if you're on the SD line, if all the points are on the SD line, then there must be a perfect correlation. If just one point is, then that means that that person has the exact same z-scores. So I think the only one is A, right? Yeah, you have the exact same z-scores for mother and father age. If your prediction error is equal to 0, you're actually on the regression line. That means we made a perfect prediction. And if you're exactly average, you're on both. So there's two things you guys should know about the SD line for the exam. So the SD line assumes R is equal to either plus or minus 1 depending on the correlation, if it's positive or negative, and it assumes that your z-scores for x and y are equal. So see chapter 6 or chapter 7? Chapter 7 if you have questions on that. Okay. Next couple of questions we are looking at. It looks like percentiles. So it says, suppose people's scores on math skills tests and social skills tests follow the normal curve but have different correlations in different countries. Consider the 5 populations below. They give us these different R values, and then we want to make a prediction. If a child's in the 25th percentile in math, estimate her percentile in social skills in each country. All right, so this question seems like it would take a lot of time if we just went through and kind of did all the steps to making a prediction with the percentile. But I know some rules from percentiles since we've been doing them. So I'm going to start with the first 3. So with R equals -1, R equals 1, and R equals 0. Let's start with R equals 0. If there's no correlation, so I'm going to start right here. There's no correlation between math and social skills percentile. If you're in the 25th percentile for math, that tells me nothing about your social skills. So I just have to guess a random percentile. And remember, we always want to guess the average if we have to guess, because most people are about average. So if R equals 0, then our prediction is always going to be the 50th percentile. Because if there's no correlation, knowing one tells you absolutely nothing about the other. We have to make an educated guess, so our best guess is always going to be the 50th percentile. So regardless of what scenario this is, that's always going to be the case. For positive 1, if R is positive 1, that means there's a perfect correlation. And if there's a perfect correlation, then your percentiles are going to be exactly equal, because you're going to find your z-score for the 25th percentile and multiply it by 1, and then you get the same z-score, so you have the same percentile. So if you're in the 25th percentile for math and there's a perfect correlation, you are in the 25th percentile for social skills. So here I'm just trying to make my life easier without doing a bunch of work for this question. And the -1 is very similar to 1. Remember, if R is -1, then your two z-scores are just going to be opposites. Like if your z-score is 1 and you multiply it by -1, it becomes -1. So if your z-scores are opposites, we saw a couple times throughout the semester that if your z-scores are opposites, your percentiles have to add to 100. This was actually, I think, a question on the previous exam too. So if you're in the 25th percentile for math and there's a perfect negative correlation, then your other percentile has to, if you do 25 plus that, it has to give you 100. So this has to be 75th. So we can always make these predictions super quickly for r equals 1, r equals -1, and r equals 0. We could do this the long way too if we really wanted to. Maybe you have some time. Maybe you like it. Go right ahead. And then the last two r's, so -0.5 and +0.5, are definitely, there's no rules for them, but we can use the idea of the regression effect, which basically says whenever we multiply by r, our prediction gets closer to the average. So for -0.5, what I would do is say, okay, -0.5 is in between -1 and 0. And since this is multiple choice, that means my percentiles have to be between 75 and 50. And there's only one that's in there. Same thing with 0.5. 0.5 is between 0 and 1. So the percentile has to be between 25 and 50. So with a table like this, you can do it quickly if you want, or you could do it the long way. And actually, for the next question, I'm going to go through the whole way that we do this, basically without the table. Let's see. Why would the percentiles be opposite? So, if you remember when we talked about the normal curve, if two z-scores, if the percentile is the area to the left of the z-score, so if your two z-scores are opposite signs, then your percentiles have to add to 100. Like, I can give an example really quick. So let's just say we have 1 and -1. Here's 1, here's -1. So for -1, the percentile is this. It's the area to the left, right? And for +1, I'll highlight it. The percentile is going to be the area to the left. So if I add the blue area plus the like shaded black area, then I'm technically taking this blue area plus the two tails are equal, right? So they have to add to 100%. So that's always the case. If you didn't know that, again, you can go ahead and just work through and solve the percentile. I'm going to look at a couple more questions. Where in the notes is this reflected? There is an example in chapter 8 with percentiles, and you'll actually see, I think on that example, 2 percentiles. I think it's 80th. This is like totally off the top of my head, but I think it's 80th and 20th percentile, and you'll see that they have opposite z-scores. And then on the homework 8, I think it was, there was a bunch of practice with this. Go back and do that question if you want more practice with it. All of the homework you can do again on Lon Kappa. There's a folder called Copy of Practice Homework, and you can do those with different numbers. Every time you open it, it'll give you different numbers. Let's see. I am going to, I'll explain this one again, just in case anyone missed it. So basically, r equals 0, r equals 1, and r equals -1. I kind of skipped the steps for doing this and just thought about what that means. So r equals 0, no correlation between math and social skills. Knowing math tells me nothing about social skills, so I just have to make a guess. So I guess the 50th percentile. R equals 1. So if r equals 1, then my z-scores are going to be the same, right? Because the steps for, we can actually see down here in questions 40 through 43, we can see the steps for going from a percentile to a predicted percentile. We have to find the z-score, multiply by r, and then find the other z-score. So if r is 1, my z-scores are going to be the same. So the area to the left, or the percentile, is going to be the same. So I knew that this one for r equals 1, I knew that the percentiles had to be equal. And then for r equals -1, your z-scores are going to be opposite signs. So they have to add to 100. What is everybody saying? Perfect. Thanks, TAs. You're doing great. And then for the last two, for the negative 0.5 and 0.5, I again did this shortcut. I basically said, okay, negative 0.5, that is in between -1 and 0. And we know the percentiles for -1 and 0. For -1, it's 75. For 0, it's 50. So I said, oh, negative 0.5 is in between there. So I can just go ahead and pick this because it's multiple choice. Same with 0.5. I said that's between 0 and +1. So my percentile has to be between 25 and 50. So that's where I got that. And again, like I said, if you'd rather do it like the next question, we can go and do that. Somebody said, what happens if it's not multiple choice? Yeah, then we'd have to actually calculate it. So I'll go ahead and fill in this table, and that'll show you another way to do these types of problems. So the 38th percentile, I am going to start with 0 in the middle, and I know that 0 is the 50th percentile. Okay, so I'm going to go ahead and find the, well, I guess it's asking me a question. What middle area on the table should you look up to find the z-score? So I'm going to find the z-score. I know that my z-score right away is going to be negative, right? Because 38th percentile is going to be somewhere over here. And what that means is that the area to the left of this negative z-score is 38%. So this is 38%. So I don't want to, this is, I guess we did this in exam 1 too, but I don't want to look up 38% because my normal table gives us these middle areas. So, and 38 is my percentile. So to find the middle area, what you can always do is say, how far is your percentile from 50? So how far is 38 from 50? 12, right? So that's half my middle area, and the normal curve is symmetrical, so I can double it. So my middle area that I'm going to look up to find my z-score is 24%. Okay, so I'd go ahead and look that up. Let's see, I have a normal table here. 24%. Looks like the z-score is about 0.3. That's the closest one. Let's go back here. And I remembered mine is negative. I definitely want the negative version. Here's the positive version. So 24% is the middle area between -3 and +3. So if it's negative, I always like to make note of that. Make note that it's going to be negative because it's easy to forget. So if you're in the 38th percentile for math, your z-score is -0.3, and then I want to make a prediction for their social skills, and the correlation is 0.5, so it's positive. So I'm going to multiply by R, and I end up getting -0.15. And then now the last part of this says, okay, what is -0.15 as a percentile? So I would go ahead and mark, here is -0.15. Percentile, remember from exam 1, is always, percentile is always the area to the left of z. Area to the left of the z-score. So here's my z-score, -0.15. My percentile is going to be all of this area to the left. And so I can figure that out by saying, oh no, oops. Well, there's percentiles from exam 1. Sorry, you guys, there we go. Okay, so if I look up 0.15, that will give me the middle area between +0.15 and -0.15. And then I can use that to find the percentile. So let's see, where's 0.15? It's down here, right there. Middle area is about 12%. So this is 12%. And then to find the percentile, so I don't want to put 12. That's not my answer. The percentile is the shaded blue area. It's everything to the left. So I can find this tail by taking 100 minus the middle area and dividing by 2. So 100 minus 12 is 88, divided by 2 is 44%. So I predict you're in the 44th percentile. Cool. So I'll tell you guys watching this review right now, there is a question like pretty much exactly like this on the test on Wednesday. So if you want more practice, there's one on pretty much every practice exam, and then that homework 8 gives good practice too. We always round the percent to a whole number. I always do, just because I don't have a calculator. My calculator's in my office. I haven't been in my office. So I always do just so I can do the calculations in my head. But on the test, something like that would be multiple choice. So you just pick the closest answer. All right. That looks good. Let's do this next question. Someone said, could we also solve by thinking 12 divided by 2 is 6, and 50th percentile minus 6 is 44. 12 divided by 2. 12 divided by 2 is 6. Yeah. That definitely works, sure. There's a bunch of different ways to do that. Yeah, that's good. Whatever you like best is great. Cool. Okay, so this next one pertains to a roadside drunk driving test. Supposedly 10% of those who get stopped and tested for drunk driving are really drunk. Okay, 70% of drunk drivers will correctly fail the test. 30% of sober drivers will also fail the test because they're scared. Fill in the table for 100 drivers total who get stopped and tested. Wow, there are a lot of typos on this exam. There we go. So with these, so this is a conditional probability question, because if I look at questions 47 and 48, they're asking me what's the chance of something, and I can fill in the table to help me answer this. So we always want to fill in the total column first. So someone asked me about this today at office hours. They said, how do I fill in the total column first? And the question will always give you information about that total column. So we have drunk drivers and sober drivers. We either want to know what percent of drivers are actually drunk or what percent of drivers are actually sober. So let's see. Okay, here we go. I see it. It says, suppose 10% of those who get stopped and tested are really drunk. So of the 100 people, 10% are actually drunk. So I could do 10% of 100. I like when it's 100 because easy math. So that's going to be 10. And then the rest, and I know how many are sober, 90% have to be sober. So this should be 90. That looks great. And now I can just fill in the rest of the chart. So what else does it tell me? It says 70% of the drunk drivers will correctly fail the test. So this is correct, right? If they're drunk, they should fail. They should pass if they're sober. So let's see, 70% of the 10 people, 0.7 times 10 is just 7. So 7 of them will correctly fail. 3 of them will pass. Yikes. And then it also says 30% of sober drivers will also fail the test. Okay, so of these 90 people, 30% of them will fail. So 30% of 90 is 27. And then the rest of them, 90 minus 27, which is 63, will correctly pass. Cool. So then I can go ahead and find the totals. So let's see, 7 plus 27 is 34, and then 3 plus 63 is 66. And now hopefully these questions will be a lot easier. It says if a driver fails the test, okay, so there's 34 drivers, let's see, there's 34 drivers that failed the test, right? What's the chance that he or she is really sober? And then 27 of those 34 are actually sober. Dang. That's kind of crazy. And then to get this into a percent, I can just put it into my calculator, 27 over 34, and then multiply it by 100. And I end up getting definitely over 50. I end up getting 79%. It says if a driver passes the test, so we know they're one of these 66 who passed the test, what's the chance that he or she is really drunk? So if they pass, only 3 of them are drunk. So that ends up being 4.5%. If we do 3 over 66 times 100, I get 4.5%. So I like doing the tables just because then you can answer the questions really quickly. You could also check your work with Bayes' rule if you're into that. That works as well. Somebody said, why isn't it 0.7 times 100 for the first column? For the first column, it says 70% of the drunk drivers will fail the test, and there's only 10 drunk drivers. If it says 70% of all drivers would fail the test, then that would be the case. Someone said, do we have to fill in the table during the exam? Yeah, there is a question about the table during the exam. Cool. So that was our first probability question. Let's see. What do we have next? So questions 49 through 54 pertain to the survey questions. What's the fastest you've ever driven in miles per hour, and what's the most you've ever drank in a 24-hour period? Interesting. And it says make regression estimates for students A and B by filling in the table. So regression estimates, that is just another word for make predictions. And it looks like they want us to use the 3-step process. So we can do that. You can always, if you have time, you can check your work using the regression equation if you want. But here it tells me specifically to do the 3-step process. So student A is 106 miles per hour. Their z-score is just going to be that value minus the average for speed, which is 96, divided by the SD, which is 20. So I have 10 over 20, or 0.5. And then to go ahead and multiply by R, we need to do that to get my the next z-score, the predicted z-score, and 0.5 times 0.4 is 0.2. And then we want to convert that back into a value. So I'm going to use the rearranged z-score formula. Value equals average plus z times SD. And now I'm looking at drinks. So the average for drinks is 13. My z-score is 0.2. The SD is 10. So that gives me 15 drinks as my prediction. Somebody said, what's the 3-step process again? That's just this. What we're doing right now. So basically convert to z-score, multiply by R, and then convert back to an actual value. So it's one of the ways that we can make predictions using regression. Somebody else asked a question I just saw in the chat about the total. I will always give you guys the total, like here it was 100. But honestly, even if I didn't, you could just always make it 100 because we're looking at the percentages or the ratios. So the total doesn't really matter, but I'll always give it to you just to keep things straightforward. All right, let's do this next one. So student B, they actually give us her drinks. So we're predicting speed from drinks instead of the opposite direction. So you just do the exact same thing we don't have to do anything special. We're just starting with a different variable. That's the nice thing about the 3-step process. It's always the same. It's always convert your value to a z-score, multiply by r to get your second z-score, and then convert back to an actual value. So student B, let's see, their z-score is going to be their value minus the average for drinks, which is 13, divided by the SD, which is 10. So what is this? 20 over 10, 2. Z-score is 2. And then I'm going to multiply by r to get my second z-score. So 2 times 0.4 is 0.8. And then the very last question, I am going to convert that back to an actual value. So let's see, I'm going to do value is equal to the average for speed is 96, plus my z-score is 0.8 that I just found, and then the SD is 20. And that gives me, when I solve that, I get 112 miles per hour. So that's my prediction. You drink 33 drinks. What is this? Oh my God, in a 24-hour period. Whoa, baby. We predict your fastest speed is 112 miles per hour. Crazy. Will this be in table format on the exam? Yes, it will. Cool, that looks good. Question 55 is a standalone one. It says in 2010, millions of students nationwide took the math and verbal SAT tests. Within each state, the average verbal and average math SAT scores were calculated, and the correlation was 0.97. Okay, so it was super high. But does that mean the correlation between the millions of individual students would also be 0.97? Okay, so they're saying if we looked at each state and made 50 points representing the state's averages, they had a really high correlation. They're saying if we look at everyone, the millions of students, would our correlation be 0.97? And this is the idea of ecological correlations, which basically says the less points you have, so the less points you have, the less scatter. And if there's less scatter, there is going to be a higher correlation. So if we looked at millions of people, there's probably going to be outliers. There's going to be a big blob of points that probably doesn't have as strong as a pattern, as strong of a pattern. So I'm going to say that R would be lower for the millions of points. R would be lower. Yeah, it looks like B is good. No, the correlation would likely be lower because there would be a lot more scatter. The points probably wouldn't follow a straight line. So this is the idea of, it was called ecological correlations, and that was from chapter 7. Somebody said, can we pull out the z-score table during the exam? Yes, of course. The z-score table, you can use the one in your book. You can print one out, and I'll have a normal table in the exam folder. This person said they didn't find it the last time. It's just like right when you click on you'll click on the exam 2 folder, and you'll see the exam, and then it'll say click here to download the normal table. So that'll definitely be there. Cool, that looks good. And then another situation, regression, it looks like. It says we're looking at father's heights and daughter's heights. There is a correlation of 0.7. They give us the averages and SDs. And it says to find the regression equation for predicting father's heights from daughter's heights. Okay, so first find the slope. So the slope of the regression equation is m, right? This would be y equals mx plus b, slope intercept form. So m is just r times SDY over SDX. Obviously, you guys do not need to memorize this because you can use your notes. So that's nice. R is 0.7, and then SD of y and SD of x. So we need to decide which variable is x and which one is y. Interesting. Okay. So remember to do this. Y is always what you're predicting. I'm actually going to write that down. Y is always what you're predicting. So here we are predicting father's heights, right? Predicting father's heights from daughter's heights. So father's heights is going to be y, and daughter's heights is going to be x. Okay, so I can even label this is y and this is x. So here you'll notice that this is, I'm going to say this to you guys on Twitch live review. So students always ask me in the semester, they're like, oh, do you just put the first variable as x and the second variable as y? No, I actually don't. I can, this one, the first variable is y. So be very, very careful on the exam on Wednesday that you know which one's x and which one's y. The first one isn't always x. So y is always what you're predicting. Remember that. If you remember that, you'll get this question right. But yeah. So that is a secret hint. That's not really a secret, but you should know that. All right. Anyway, back to this. So the SD of y is 2.5, right? And the SD of x is 1.5. And then if I do this math, I end up getting, I think it is 1.17. Yeah. So I can plug this in. Slope is 1.17. And now it wants me to find the y-intercept. So what I have is y equals 1.17x plus b. The y-intercept is b. So I want to find b. So in my equation, I have 3 unknowns, but I can plug in the 2 averages for x and y. So y, the average for y is 69 inches, right? The average for x is 64 inches. And now I just have b by itself. So now I can go ahead and solve for b. And when I do this, I think I get this. B equals negative 5.88. So now I have my regression equation. Okay, so that's great. That's the point of that. Well, now I can go ahead and make predictions. So given any x, given any, what is my x again, daughter's height, I can predict the father's height. So 58 says use the regression equation to predict the height of a father whose daughter is 62 inches tall. Round to the nearest whole number. Okay, so I'm going to use my equation. Y equals 1.17. X they're giving me is 62 minus 5.88. And I end up getting 67 inches. So this should be C. All right, suppose our regression line predicts that a father's height is 64 inches, but his actual height is 70 inches. What's his residual? So the residual is how far off was our prediction. So the residual is the actual minus the predicted. Residual is also known as prediction error. So it says his actual height is 70. We predicted it was 64. So 70 minus 64 should be 6. Remember, the average of the residuals is always 0. What is the SD of the prediction errors? So that is, the SD of the prediction errors, or the RMSE, is basically, if I wanted to describe what that is, it's telling me on average how far are the points from the line. If the RMSE is big, the points are really far away from the line. If the RMSE is really small, the points are close to the line. So I'm still predicting father's height. So the formula here is for RMSE is the square root of 1 minus r squared times the SD of y. So the SD of y in this case is 2.5, so it should be D. Somebody said, is the prediction error always positive? It depends. If your actual value is lower than your predicted value, then it's going to be negative. So it's not always positive. There's positive ones and negative ones. It just depends. Somebody said I got 1.67. What did I do wrong? I think you might have switched up which one was X and Y. I think. So remember, I'll say it one more time. So if any of you guys watching this Twitch review, when you do the exam, you're going to get this right? X and Y is always what you're predicting. So I think if you switched up the X and the Y, I think you get 1.67 as the slope. Right? Am I right? Someone tell me if that's not right. Here we go. Let's do this. Remember, for Wednesday. I think the person that is getting the wrong answer for the slope, I think maybe you forgot to multiply by r. Try multiplying by r. It's definitely 1.17. Thanks, Sharon. You got the one that said, how do you know to use 64 and not 67? The regression line predicts that the father's height is 60. Just, it would say to use the answer from the previous question if we wanted that. Cool. Okay. So, 61. It says, of course, the predictions we made in question 58. So we predicted 67 inches. This is our prediction. Isn't always going to be exactly correct, right? Because regression it's our best estimate, but unless there's a perfect correlation, we're not going to be making perfect predictions every time. It says instead there's a range of father's heights with about 95% of them falling within what range. So here we basically want to add and subtract something to make this into a range. And 95% corresponds to a z-score of 2. So this should be 2 RMSEs or 2 SD errors. RMSE and standard deviation of the errors are the same thing. So this is nice. We don't even have to figure out what that range is. We just have to know it's going to be within 2 RMSEs. If this said, instead of 95, say it said 68, that corresponds to a z-score of 1, then our answer would be A, if that was the case. All right. So we're nearing the end. There's one more part of this exam, and it's the probability part. So hopefully regression, correlation, box plots, all that stuff is making a little bit more sense now. But if there are no other questions, I am going to go ahead and move on to the next one. Somebody just asked a good question, though. They said, in question 60, how do we know if the number is 2.5 or 1.5? So the formula for question 60 up here, formula is r times the SCY, that's not the formula. The formula is this, square root of 1 minus r squared times the SD of y. Remember, y is what we're predicting, which is father's heights. So that's why I know it has to be 2.5. Cool. All right. Probability. So it says questions 62 to 66 pertain to this table. So this is just reading a table. They give us all the data. This was, who do you fan for vote? Oh, this is old data. I guess 2012 election. I'll give you guys some new data on the next exam 3 about our election survey questions. Okay, it says, what's the chance that you'll draw a student voting for Romney? Okay, so Romney is right here, right? 91 students are voting for Romney out of 590. That looks good. It doesn't say anything about them being white or non-white. And then 63 says, what's the chance you'll get a student voting for Romney if you only draw from the white students? So let's see. So now I'm only drawing from these 389 white students. So that's going to be my denominator. What's the chance I'll get them voting for Romney? Should be 82. 64 says, what's the chance of getting a white student if you only draw from the Romney voters? Okay, so there are 91 Romney voters. Oops, here we go. 91. And what's the chance I get a white student? Again, should be 82. 82 over 91. There we go, E. 65 says, what's the chance that a randomly selected student is either voting for Obama or white? So here, this or, we're going to go ahead and use the addition rule. So I'm actually going to write at the top of the page. The addition rule says that the probability of A or B is equal to the probability of A, or means to add, plus the probability of B. And then we have to subtract the probability of both because we don't want to double count anyone that's both. We don't want to count them twice. So let's see, I'll go ahead and do this, voting for Obama or white. So first I'm going to figure out what's the probability they're voting for Obama, which if I look at the Obama column is 331 out of 590, plus the probability that they're white, which is, if I look at the white row, 389 out of 590. And then I have to subtract the probability of both, if they're white and voting for Obama. And it looks like here, there's 207 of those. And that ends up giving me, I think it should be the first one, 513 out of 590. Cool. So that's the addition rule. Just remember not to double count. The last one says, draw 3 students with replacement. What's the chance that at least one of them is a Romney supporter? So this is one of our 2 special cases. I'll write this at the top too. The probability of at least one of something is going to be 1 minus the probability of none. So here, the idea is at least one is complicated, because 3 students, at least one can be 1 student, 2 students, or 3 students. That's 3 separate probabilities. Instead, the only thing not included in at least one is none. So I'm going to do 1 minus that to get my answer a lot faster. So here my answer is going to be 1 minus the probability that none of them are Romney supporters. So the chance that they are a Romney supporter is 91 out of 590, right? If I look at the Romney column. So the chance that they're not a Romney supporter would be 590 minus 91. So that would be 499, right? And we're drawing with replacement, so that means we're going to take a student out and put them back in. So the denominator never changes, so I can just go ahead and cube that answer. Okay, and then I'll go ahead and write down, just while I have them at the top, the other 2 rules that we learned. The first one is the other special case. The probability of not all of something is complicated. It's easier to do 1 minus the probability of all. And then the last thing that we learned is the multiplication rule, which says if we're looking at the probability of 2 events, A and B, as long as the 2 events are independent, we can just take the probability of A times the probability of B. If the two events are not independent, then you just need to remember the probability of B you calculate given that A already happened. So we'll do an example of that in the next question. But I'll see if there are any questions. It looks like no so far. So let's keep going. It says questions 67 through 70 pertain to a well-shuffled deck of 52 cards. Okay, so the cards, it says how many of each things that there are. Draw 2 cards without replacement. What's the chance that they are both diamonds? So we want to know what's the probability that we draw 2 cards and we get a diamond and a diamond, right? Both diamonds. So the chance I get a diamond on the first draw, it says there are 13 diamonds. So that's just going to be 13 out of 52. And means to multiply. This is without replacement. So I only have 51 cards left. And then I took out one of the diamonds already. So I only have 12 diamonds. So this should be B. 68 says to go ahead and draw 2 cards with replacement. What's the chance that they're both spades? So I want to know what's the probability I get a spade and a spade. So I'm using I guess I've done this the whole exam, but the P and then the parentheses is read as probability of something. So the chance I get a spade on the first draw, there are 13 spades, so that's 13 out of 52. It is with replacement, so I'm going to put the spade back in, and then my chance on the second draw is still 13 out of 52. So it looks like that is D. Number 69 says to draw 1 card at random. What's the chance that it's either a jack or an ace? So the probability that I get a jack or an ace is going to be probability that I get a jack plus the probability that I get an ace minus the probability of both. So the chance that I get a jack, there are 4 jacks, right? Yeah, 4 out of 52. Plus the chance that I get an ace, there are 4 aces. And I'm getting this from the original question, told me all the details that I need to know. And then minus the probability of both. So we need to know, are there any cards that are both jacks and aces? And the answer here is no. So my answer is just going to be 8 out of 52. Kind of a similar question, number 70 says, what's the chance that if we draw 1 card at random, it's either a queen or a club? So that's going to be the probability that I get a queen plus the probability that I get a club minus the probability of both. So here, the chance I get a queen, there's 4 queens out of 52 cards, plus there are 13 clubs out of 52 cards, and then are there any cards that are both queen and clubs? Well, it says there's 1 queen of clubs in the deck, so I'm going to subtract the queen of clubs to get 16 out of 52. Somebody asked, for question 69, it's because they are mutually exclusive, right? That is exactly right. Yes, great. They cannot happen at the same time. Someone also asked previously about the number of questions, I think. Somebody said, like, how many questions are there? Are there 60 or 70 questions? I don't remember exactly how many there are on exam 2 off the top of my head, but they'll be between 60 and 70. I think exam 1 I had 60. Yeah, there might be a little more, but you still should have plenty of time. Okay, let's keep going. 2 dice are rolled. What's the chance that the sum of the spots is 3? So let's see, how many ways are there to get a sum of 3? I could get a 1 and a 2, or a 2 and a 1. If I roll 2 dice, there are 36 options. So this should be 2 out of 36. 1 die is rolled 4 times. What's the chance of getting no 2s? So I can get anything except a 2. So the chance of not getting a 2 is 5 out of 6, right? And I want to do that 4 times. 1 die is rolled 4 times. What's the chance of getting at least 1 2? So at least 1 is one of my special cases. So the only time that you're ever going to have the 1 minus in your answer is if it says at least 1 or not all, right? Those are our 2 special cases up at the top. At least 1 or not all. So looking at all these questions, the only time, so here's at least 1, and our answer did have a 1 minus in our answer. Do any of these other ones say it? Here's at least 1, here's not all. So those are the only 3 questions, the ones that I highlighted in blue, that are going to have a 1 minus in the answer. So I can right away for question 73 get rid of almost all of the options. So the question is, which one is it? So at least 1, remember we're going to do 1 minus the probability of none or no 2s. And 1 minus the chance of getting no 2s, chance of not getting a 2, again, is 5 out of 6. So we actually just found the chance of getting no 2s in number 72. So this should be C. 74 says 1 die is rolled 3 times. What's the chance of getting all 2s? So the chance of getting a 2 on the first roll is 1/6, and we want to do that 3 times. Nice thing with the die is that the probability is always the same. There's no with or without replacement that you have to worry about. But here for all 2s, I would immediately get rid of the 1 minus because those are only for at least 1 and not all. Ooh, here's 75, not all 2s. So that is just 1 minus the probability of getting all 2s. That's our other special case, the not all. So it's basically going to be 1 minus, and then the chance of getting all 2s is 1/6 cubed. Cool. Question 76 says 1 die is rolled twice. What's the chance that the first roll is either a 4 or the second roll is a 5? Okay, so again, I could do the addition rule if I wanted to here. The probability that the first roll is a 4, so first roll is a 4, or the probability that the second roll is a 5, and then I'd have to subtract the probability of both. So the chance that the first roll is a 4 is 1 out of 6, right? Chance that the second roll is a 5 is 1 out of 6. And then for both, the question is, what does that actually mean? So both means the probability that the first roll is a 4 and, right, the second roll is a 5. So for and, we just multiply. So the chance the first roll is a 4 is 1/6, and means to multiply. Chance that the second roll is a 5 is 1/6. So this is 1 out of 36. So I do have to subtract the 1 out of 36. So this one should be D. This one is sometimes kind of throws people off. You could also look at the you could also look at the chart at the beginning of chapter 12, which gives you all the outcomes for rolling 2 dice. Question, someone said, do you only subtract the 1 out of 36 for the addition rule, not the multiplication rule? Yes, exactly. You could also, I guess, think of this as, for this question, for question 76, you could think, okay, what's the chance that the first roll is a 4? Well, you can get a 4 and a 1, 4 and a 2, 4 and a 3, 4 and a 4, 4 and a 5, or 4 and a 6. So the chance that the first roll is a 4, first roll 4 is there's 6 out of 36 options, which simplifies to 1/6. Or the chance that the second roll is a 5. Well, you could get a 1 and a 5. You could get a 2 and a 5, 3 and a 5, 4 and a 5, 5 and a 5, or 6 and a 5. So the chance that the second roll is a 5 is also 6 out of 36. And you'll notice that I actually counted the chance of getting both, so getting basically a 4 on the first roll and a 5 on the second roll. So I counted this one twice. So that's why when I count up all these options, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, already counted that one, 10, 11 out of 36 is what this simplifies to. So this simplifies to 11 out of 36. So there's, again, with probability, there's a bunch of ways to solve each of the questions. It might be more visual. Maybe this will help. Or if you like the formula, that works too. Somebody said, but we're only rolling one die, right? So we're rolling one die twice for 76. For 78, though, 78 says a die is rolled once. So in 76, we're rolling twice. So you can get a 4 on the first roll and a 5 on the second roll. Not in 78, though. 77 says one die is rolled twice. What's the chance that the first roll is a 4 and the second roll is a 5? Oh, I guess we just found that out, right? Should be 1/6 times 1/6. Okay, and then the last question, question 78, a die is rolled once. What's the chance of getting a 4 or a 5? Here, if we're rolling once, we can't get both. So this should just be the probability of getting a 4 plus the probability of getting a 5. We could say minus the probability of both, but that ends up being 0 for just one roll. So this is just 1/6 plus 1/6. And I think I answered all of them. So I'll see if there are any questions. It is, okay, it's 8:36. So that took me, like, going through this pretty slow and showing all my work and going extra slow. It took me about an hour and a half or 90 minutes to do this. And there were 78 questions. So I think you guys should be good to do. At most on exam 2, there's going to be 70 questions. I can't remember how many there are, but you should be good for time. Any questions? Somebody said, what are the main things that will be on the exam? Box plots, correlation, regression, and probability are the 4 main things. When will this be posted? I will try and post it tonight. I have to edit it, so it will take a little bit of time to post, but it will be posted by 9 a.m. tomorrow. If I post it earlier, I'll email you guys. Lots of questions. Let's see. Can you explain questions 17 through 20? Like, when does R change? Let's see, 17 through 20. 17 through 20, so R only changes if you're doing the same thing to every number on the list, which we're doing for 17 through 20. We're doing the same thing to either all the Y's or all the X's. The only time R changes is if we multiply or divide by a negative, and it changes signs. If you just change one number in the X's or Y's, then it's going to change, but we don't know how. Oh, thank you guys. I'm glad this was helpful. Okay, somebody wants me to show pages 1, 2, and 3. So they can take a picture of the answers. The answer key is actually online, so you might want to just do that because I don't think I can show. Can I? Oh, I guess I can. Let's see. Here's number 1. Trying to see if I answered all these questions. Yeah, if you're having trouble with probability, I'd recommend doing the practice homework or doing like the last page of all the practice exams. Honestly, another good thing to do is to watch that part of the lecture again, or what day is it today? Today's Monday. So we have office hours tomorrow. If any of you guys want me to go through another one of these, any of these questions again, you can definitely stop by our office hours. Right now, I'm not going to go through the questions again just because of timing. But if you have questions, you can stop by tomorrow or send me an email or post on Piazza. Thanks, guys, for the belated birthday. Let me see. Any more questions? The TAs are giving good responses. Here's page 3. I'm just gonna go through these again. Somebody asked about question 26. So 26, if you got 21 through 25, 26 we know the box plot is going to have a high outlier. So I know it had to be either B or E. And then the lowest number on the list, the bottom whisker represents the lowest number on the list. So ours is -3, so I know it can't be E because E doesn't have any negative numbers if you look at the y-axis. So it has to be B. Oh, this is a good question. Someone said, are you going to do extra credit if we fill out our notebook? I normally do, but I can't this semester because I can't collect them, and there's too many. There's 1,500 students, so I probably won't have time during finals week to go through 1,500 videos of notebooks, I guess is what we would do. So instead, we readjusted the bonus points. You'll still get, actually this semester, if you do all of the bonus points, you get more than you would in any semester. So I adjusted the bonus points so that you'll still get extra credit, just not from filling in the notebook. But the surveys are worth more, and so are the pre-lectures. So if you haven't been doing those, you still have plenty of time to do those throughout the semester. What lecture would 26 be from? The first one for exam 2, the box plots one, the very first one in exam 2 material. Don't worry if you missed some of the surveys and the pre-lectures. We have pre-lectures every single week. And then the surveys, if you missed one, it's not a big deal at all. Plenty more where that came from. There's still 2 more surveys. Where can we see our grade with the bonus? So your grade, if you go to the syllabus, it shows how I calculate your grade with the bonus. Basically, you just take your bonus points, divide that by a number, and then add that to your grade. In Compass, I can't put your grade with bonus until the very end, but you can easily calculate it, or if you have questions on that, you can come to office hours and I can calculate it for you. Cool. I think I think that's about it. But like I said, if you guys have more questions, I will be at office hours the whole time tomorrow, 2 to 5 on Zoom. Come by and say hi. I hope you all have a great night, and hopefully this review was helpful. Best of luck on the exam. You guys will do great. And if there's anything else I can do, just send me an email and let me know. Bye.